Hello, this is Alan Elliott, and this is SAS Essentials Mastering SAS for Data Analytics, 3rd edition. This is part 1 of Chapter 6, Preparing Data for Analysis, Advanced SAS Programming. In this chapter, we're going to be looking at SAS functions, how to use PROC transpose, how to perform data recoding using select, and how to use SAS programming to clean up a messy data set. If you want to follow along with the hands-on examples, please make sure that you've downloaded the files from this location. So let's get started. Section 6.1 is using SAS functions. A number of sophisticated calculations can be made in SAS using functions. These functions include arithmetic and text and date manipulation and some others. For example, the format of a typical SAS function would be result equal, and then whatever the function is, and optionally several objects or arguments in the function in parentheses. Each argument is a piece of information that you send to the function for it to act upon it and return a result. Functions can require one or more arguments. Some require no arguments. For example, here are a few mathematical functions like absolute value. Notice all of these take one argument. The variable is shown as x there. It could be anything. It could be an actual number or a variable. Factorial, integer, natural log, and square root, and there are many others. There are actually several kinds or types of functions in SAS, and we're going to look at some of these. Arithmetic, trigonometric, data and time, character, truncation, special use and miscellaneous, financial, and accessing previous observations, or a lag. So to use functions in a calculation, we typically would then use this in a data step where we put a mathematical phrase or equivalency here, where we have on the left-hand side of the equal sign, we have the variable where we want the result to go or to be sent, and on the right-hand side after the equal sign, we have some sort of equation or arithmetic or character series of functions or other things. In this case, for instance, we have measure, and that would, assuming that that's a number, plus the square root of, again, a and b are variables, so a squared plus b squared. That would calculate the square of a and then the square of b, and then add those two numbers, then take the square root of that value, add that value to the value of measure, and assign the result to the variable named c. Some arguments take more than one. Some functions take more than one argument, and here are some examples of those. For instance, the max function. If we have a list of variables in the max function, it's going to return the maximum of whatever the list is. Similar with minimum, the sum function is going to give us the sum of a list. The median is going to find the median of a list, and the round is going to round off a value according to, as we're going to see a little bit later, to some number of decimal places. Here's an example. Total equals sum, time 1, time 2, time 3, time 4. What that's going to do is sum up all those four values for a particular record and then return it to the variable total. Rounding values, it uses the round function. So the round off function determines how the rounding will be performed. The default is always 1. A round off value of 0.01 means to round off to the nearest hundredth, and a round off value of 5 means to round off to the nearest 5. So here are some examples. So if I say round of 3.1415, comma, 0.01 says return this value to 2 decimal places. So it's going to give me 3.14. Now, it's going to round that. So if that happened to be 3.16, or If that would happen to be 3.146, it would have returned 3.15 because it will round it to the nearest uh, number there. And then round 107 comma 5, again, that means return the nearest 5, so 105 would be the answer. And then round 3.6234 returns the value 4 because it rounds to the nearest integer. There are some functions with no arguments. Here's an example of one, the today function. So if I have an equation now equal today, and then the empty parentheses, it's going to return the current date value from the computer's clock into the variable we called now. To specify arguments, we can either assign a number to a variable, or the variable can be part of a data set that we're using. So in this example, we're assigning some values like x1 equal 1 and x2 equal 2 and so forth. And then we can use those values or the numbers themselves in a function. So here's some examples. So if I have max 1, 2, 3, 4, and 5, that's going to return 5 because it's the largest value. Max of x1, x2, x3, x4 is going to return x3 or 13 because that's the largest value. And if I say max of x1 dash x4, that means all the values from x1 to x4, it's also going to return the value 13. All right, let's look more about this specifying arguments. And one of the examples on the previous slide, we saw we had of x1 dash x4. And why didn't we just put x1 dash x4? There's a different meaning depending on whether you use the of or not. And the important thing to know is that if you do use of before a list like this, it means that if there are missing values in the list, they're ignored. And we'll see more about that in the next slide. But let's just look at how that would be used down below. So if I have min of x1 dash x4, it returns the value of 1, even if there's a missing value somewhere in that list. And the other ones there, ones of interest may be in miss, the number of missing values in x1 through x4. It turns to 0 because in this case there are none. And n of x1 dash x4 returns the number of non-missing values. So what if there are missing values in a list? So let's create this data set called num. x1, x2, and x3 have values, but x4 has a missing value. How is that going to affect these calculations below? So you notice m1 is the sum of x1 dash x4, and m2 is the sum of x1 dash x4. Now, what's going to be the difference here? Now, as we defined it, when we use the of, it ignores the missing value. So m2 is going to ignore the x4. However, m1 is going to include the x4 in the sum. Now, SAS always creates or produces a missing value whenever there's a missing value in a calculation. So let's look at the results. So the answer is given here. Now notice here we have m1 is the sum x1 dash x4 without an OF. And since it has a missing value in that list, then SAS is going to return a missing value for m1. So if you notice down at the output where it says m1, you'll see that there is a missing value indicated. Whereas m2, the sum of x1 dash x4, it ignores that missing value, and so we get the result 16. So let's do hands-on example 6.1. Open the file called ddates.sas, and you'll see this is what it looks like. We're inputting a variable called bdate, birth date, and then we're also defining a target date. So here we're looking at how to use some various functions, and all of these functions are listed in an appendix in the back, so you can look these up as you need them. But the target value is going to be created by the function mdy. And this function, we put in there a month, a day, year, as you can see 8/25/23, and it returns a date value into target. So we have the target, and then we're going to create a value called age, and we're using a function called intck. Now that's going to return the integer of a difference between two values. So here we have the designation year, and then B date and target. So it's going to return the number of years between the birth date and the target date. If we put month in there, for instance, it would return the number of months between those two values. All right, so we have our initial information there, and then our data lines. We're going to read in 3 dates, and as you can see there, and then SAS will, as it reads it in, it's going to calculate target and age, and then the PROC print will print out the results of B date and target. Well, it will format B date and target, and also give us the age, the difference that it found. And so here's the result. So here we see birth date, and we ask it in a particular format. Target is in a different format, and then age is that difference it calculated. So target minus birthday gives us age, and that's the numeric or an integer value of the difference between those two dates. All right, let's look at section 6.2. This is using PROC transpose. Now, PROC transpose allows us to restructure the values in a data set by transposing or reorienting the data. This is typically performed when your data is not in the structure you require for an analysis. And as we're going to see in the upcoming examples, sometimes you get a data set that is not structured the way you need it, and oftentimes you need to flip the data or transpose it. And this will show you how it's done. Basically, we have data in rows. We use PROC transpose to turn it into columns. So here's the basic syntax of PROC transpose. We read in a data set using the data statement. We output a new data set using the output. Then we can define several things. The prefix specifies the prefix to be to the names of the variables created by the transposition. So we're going to create new variables. What do we name them? And by default, SAS is going to name them call1, call2, etc. But we can define our own prefix if we want to. The by variable, when specified, indicates the variables that are used to form the by groups. And the var statement specifies which variables are to be transposed. So let's look at a specific example. Open the file called dtranspose1.sas, and notice that we have, we're reading in, instead of columns of variables, the columns are now subjects. So that's a little bit unusual. But sometimes you get data like this. A lot of times when people are collecting data, this is how they collect it, and so they enter it into Excel or something, and you import it in, and now you have this data set that's flipped on its side. So what do? Well, we can do a PROC transpose. So here we read in the data subjects, and now we're going to output a new data set called transposed, and we're going to transpose sub 1 through sub 4. We simply run that, and when we do a PROC print, we can see it did, in fact, do what we wanted. Now each subject 1 through subject 4, is on its own line, and so the data is now restructured in a way that we could use it in an analysis. However, there's some issues that we might want to deal with, and that has to do with the column names and things like that. So there's various ways to do that. Let's look at some examples. So we mentioned the prefix option. What if I didn't want call1, call2, instead I want info1, info2, or something like that? Then I simply add this prefix statement here, prefix equal info, rerun the code, and now we see that instead of call1, call2, call3, I get info1, info2, info3. That may or may not be helpful to you, but it shows you a way that you can rename those columns. There's probably a better way. So let's continue with this example. For better results, let's do this. So here we're going to have data new set transpose, and now we're going to rename those infos to something else. Info1 we're going to call baseline, info2 time 1, info3 time 2, and so forth. And info5 is gender, and we're also going to rename underscore name underscore, which is the default name of the column, and we're going to call it subject. So this is just another way within the PROC transpose setting that we can get the names more like what we want. So let's see what this code results. All right, now the database is looking much better. We have a column named subject, and then baseline, time 1, time 2, time 3, and then gender. So we've gotten this data set into a way that it looks nice. We can do a report and do an analysis on it. Let's do another hands-on example. In this case, open up the file called dtranspose1a.sas. And notice we have this same data set, except there's something new in it. So oftentimes, if you don't, you might have a label for each of the lines. And so in this case, we already have labels: baseline, time 1, time 2, time 3, and gender, even though the general structure for this data set is still out of whack. So we want to fix that. However, having these labels in here allows us to do it quicker than in the previous example. Let's see how that works. Okay, so in this case, we're doing a PROC transpose. It's the same at the beginning, data subjects out transpose, but now we're going to use ID. So ID lab means use that lab variable as the labels or as the IDs in this transpose. So when we run this, now look, we get a much nicer data set to begin with very easily. The only thing we still have left is we might want to go back and rename that underscore name underscore column. But that gave us 5 of the columns with much cleaner and easier names at the very beginning. Now there's another way you can use PROC transpose, and that is dealing with multiple records per subject. Suppose we have a data set where we have more than one observation for subjects sometimes. So this is a data set called complications, where people coming into an emergency room, they were assigned an ID, and the number of complications they had was recorded. However, each complication was recorded as a separate record. So we see here that patient number 1921 had 2 complications, pneumonia and renal failure. Now, when we do an analysis, we oftentimes want to have only one subject or one entity per line. So this creates a problem. If we want to do an analysis, we may want to somehow make sure that only one subject exists per line, but we still want to retain all the information that we've gathered. So how do we do that? Well, PROC transpose gives us a way. So let's look at this code here. We can use PROC transpose to combine multiple records identified by a key variable onto one line per record. So this is how it's done. We're reading in the data set called complications, outputting it to comp out, and we're assigning a prefix here called COMP by subject. This identifies the variable or the key variable that we want to expand on. So subject is the variable where we have multiple ones, and we want to simply come out with a new data set where we only have one subject per line. So that's why it's in the by category there, by subject. And then the var identifies which variable we want to expand. So let's see how this works. So we run the PROC transpose. We're going to now print out this data set. We're going to create another data set just to give us a little bit of, make our PROC print a little easier. In this case, we're going to create a new data set called multiple out of the output data set comp out. We're going to drop the name column because that doesn't give us anything. And then we're going to say if comp3 equal blank, then remember that's a subsetting if statement. So it says that it's going to limit the output to subjects with 3 or more complications. So if complication 3 is blank, it means that they didn't have 3 or more complications. We're only interested in people with 3 or more complications, so this eliminates all of those. Now we're going to do a PROC print on that new data set, and we're going to list the first 4 complications. There's actually up to 7 in this data set, but just so we can see the results, I'm limiting it to 4. And I'm also, in the format statement, limiting the name of the complication to up to 10 characters. Again, I'm just doing this so that when we look at it, we can see the results easier. Okay, and so here are the results. Notice we have subjects and we have a number of complications. So record or subject number 2076 had 3 complications: pneumonia, heart attack, and renal failure. Notice some of them are truncated because I've truncated the number of characters in each column. So this is how PROC transpose can help us put one subject or one entity on each line when there are multiple ones in the original data set. All right, if we can continue this, we can use that information to maybe do some other analyses of this data. And here's just an example of how to do that. Again, we're just using some of the functions. I'm introducing some of the functions here that might be helpful to you. So here we're going to create a new data set called renal from the comp out data set. And I'm calculating a new variable called ccat. And what this is we're going to concatenate or add together all of the complications, comp 1 through comp 7. So what that's going to do is we're going to see in the next slide, it's just going to stack all the complications into one variable called ccat. And then within ccat, I want to find, I'm using the function called find, and I'm making sure everything is uppercase so things will match. So I'm saying find the word renal from uppercase ccat. And if the find results is not 0, not equal to 0, then I'm going to say renal failure equal yes, else renal failure equal no. So what am I doing here? I'm looking at the complications and saying if they had renal failure, if renal appeared in any of the complications, then I'm going to create a new variable called renal failure, and I'm going to say yes, they had renal failure. So otherwise they didn't. So now I'm creating a variable that's a 0, 1, or yes, no variable that's going to allow me to find out which of these subjects had renal failure and which didn't. And I'm going to do that using a PROC freak down below, where I'm going to use that new data set called renal, and I'm going to create a table of renal failure, which is going to give me the counts that I'm interested in. So let's see how that works. All right, so here is some of the output here. And again, we have this ccat equal cat of complication through comp 7. And what that did is it added the complications together. So here we see again on subject 2076, it sort of stacked all those together: pneumonia, heart attack, renal failure. So by stacking them together, we basically get everything into one variable. So now we can search it. And that's where we're going to use the find function to search through all of this information and determine whether or not the word renal is anywhere in that list. So when we do the find upcase ccat renal not equal to 0, then renal failure equal yes, else no, then it's going to look through this data. On record 21, it sees the word renal, and so it creates a new variable. The last column is renal failure, and it put the word yes there. And notice all the rest of them say no. So we have created now a yes-no variable where we've identified all the subjects that had a renal failure. So this is just an example of some of the things you can do with PROC transpose, and then use that information using some functions and doing some searches and come up with the answer that you want. There's some other steps in this example that you can follow by following the information in the text. So now let's look more closely at that code that we use to create this count that we're looking for. All of this we've seen up to this point, except let me talk about the PROC freak. So we've created a new data set called renal that contains a column, renal failure, and within that column are yeses and nos. We can use PROC freak then to count those and to categorize them by using the tables statement within PROC freak, as you see here. So PROC freak, using the renal data set, give us a table of renal failure, which is going to produce counts. So let's see what that result is. So here we have the table that was created. We see that within the data set, it found 478 no's and 50 yeses. So we've identified 50 subjects that had renal failure as a complication. Now let's look at section 6.3, the select statement. This is a handy statement that allows us to evaluate the value of a variable and create new assignments based on those values. So here's the basic syntax of that, where we say select, and then depending on some expression, we're going to create new values for a variable. So let's take a look at how that works. So suppose we want to calculate a new value according to some specific value of the variable observed. That is, if observed is 1, we want to set new value equal age plus 2. If observed is 2 or 3, we want to set the new value as age plus 10, and so forth. So we can do some fairly complicated recodings using the select statement. So let's take a look at how that works. So we say select observed. Now, what that means is now we're going to look at when various values of observed. So that when with a 1 there means when observed equal 1. Just a simpler way of saying it. So when observed equal 1, then we're going to create a new variable called new value, new val, that is age plus 2. When observed is 2 or 3, we're going to create new value is age plus 10. Or when new observed is 4, 5, or 6, then new value is age plus 20. Otherwise, if the value observed is neither 1, 2, 3, 4, 5, or 6, then new value becomes 0. So you can see how we can use this to quickly recode a variable into some new variable. Now, there's another way to use select, and that is instead of using that sort of default select, let me go back just a second. So select observed, notice this new one, this doesn't have the value, the variable listed there. Instead, in the when statements, we have a specific expression. When group is equal to A, then create a new variable called status2 equal 1. When group equal B and sex equal 1, then status2 equal 2. When group equals C and sex equals 0, status2 equal 3. Otherwise, status equal 0. So we have two sort of versions of the select statement, one with and one without a specific select expression. So just be aware that you can use them in both ways. I sort of prefer this way because I think it's more readable, and to me it's easier to handle. All right, so let's look at example 6.5. Open up the file called deselect.sas, and this contains a select statement, as we can see, using the first method here, where we say select status. When 1, 2, or when status is 1, 2, we're going to call economic low. 3 is middle, 4, 5 is high, otherwise missing. So that gives us a quick way again to recode the value status. Once we run that program, we see this output produced, and you notice in the far right corner you have a new variable called economic, and you'll see now that there are several values in this column, high, low, and middle, corresponding to the select statement and how we recoded that value. All right, so this is the end of part 1 of chapter 6. Part 2 is coming up, and the next tutorial is going to walk us through how to clean up a messy data set. Thank you for watching this tutorial. I hope it's been helpful. Please take time to subscribe and to like this channel. Thank you.